Hey everybody, this is Larry. This is me going with Q3 of the weekly contest 366. Apply operations to make two strings equal. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this farm. So this one I spent the longest on for this contest, 15 minutes. I'm really sad about it, to be honest. You could watch the live portion next, but to be honest, I spent 8 or 9 minutes or so just misreading the problem, and as a result, that's just very sad. And then I also had like another 2 minutes of debugging, but that part is okay. But yeah, 2-3 minutes. So like I would have solved this in like about 3-4 minutes, which I'm a little bit sad about. But yeah, but the biggest, so what just to kind of get it out of the way, and you should hit the subscribe button to make me feel a little bit better, or the like button, or just leave a comment in the thing about how much, like how often you misread contests or problems. But no, but for this one, I honestly just kind of misread flip. Like flipping this definition of changing it from 0 to 1, I honestly misread it as like, given these things, I thought it actually swapped, right? Like I thought this is swapping I and j, and this is swapping I and I plus 1. Misread for the longest time, and I could figure it out. I thought there was some principles about like conservation of ones or something like this where, but that said, the ideas that I was thinking about there did actually turn out to directly apply to this particular problem, and we'll go over the solve, now. The idea here, so the first thing to notice is that n is less than 500 or equal to 500 or less, which means that, you have a chance at n square algorithms, and this is basically, basically kind of what we do. So the idea here is that the two operations, and so the first idea that I kind of play around with is just having the index of x1 for all purposes. It doesn't really matter. Like this is almost like the answer key, right? The S2 is the answer key, so you almost never need to swap it. It doesn't really make sense to kind of have like two-dimensional indexing. So for me, it's just about getting the suffix of this, which means that in this case, it means that the prefix is correct and the suffix is it's up for kind of doing. Let me ask you all a little bit. That means that for this input, and the x just changed the cost, but it's the same, which is that means that if we have if we do dp, my idea was that if we have here, the subproblem is the suffix of s1, and trying to get this to match, the suffix this to match the answer key, and of course that means that everything previously has to be done. So then the next step for me after figuring that out is like, okay, well, what can we do, right? Well, we only have two operations that we can do, which is something in my hair or something. Okay. All right. So we'll do the easier one first, which is the flip I and I plus 1. That means that, okay, so assuming that we said that all the prefix has to match, that means that whenever you see something that don't match, you have to do something about it. And there are two ways to do something about it, but you have to do one of those two things. And the first one, let's say, is this one because it's easier to do, is that you flip this bit, right? So if you flip this bit, what does this mean? That means that we also flip the next bit. So then now all we have to do is that we just add some sort of a Boolean. That's right. Anyway, I track a Boolean value to say, hey, flip the next bit. And then we take this operation and flip the next bit, right? Or you flip I and j for some indexes, and it causes x, right? So this one is kind of the same idea, but it's almost the way that I think about it is just like a borrowing and lending kind of thing, right? So that means that, okay, let's say this is, these are the fourth digit is different, and we want to swap one and some other digit in the future. Well, what digit in the future? Well, we don't know, or we don't have to know yet. We could brute force for all of them. Of course, brute forcing for all of them may be a little bit slow. And maybe you could, Yeah, it probably is too slow, though, and you have to like keep track of states and some weirdness. I think that part is the more scary part. At least immediately, maybe they're both scary. But it's about like, okay, let's say I'm borrowing. Like you could call it as borrowing. I could think of it as borrowing in that regards. Is that I'm borrowing one thing from the future, so then the future has to pay it back in some way. So that's like almost like a debit account, right? That means that we use it on the I side. Maybe another way to say it is that we used it on the I side. We choose the current index to be I, and then in the future we choose the index to be j. maybe that's a more precise way of doing it. And then we have to track how many J's we have to select in the future, and we pay the cost. So that's basically it. That's basically the core idea behind this dynamic programming. And once you kind of understand that, then everything is kind of quote unquote brute force with memorization. And let's kind of go through the code with that in mind, right? So in the beginning, we just start with, index 0, no carry bit, and we don't land anything in the future. Of course, if it's infinity, do -1. Otherwise, you have this thing, right? So we'll go over it line by line just to kind of, annotate this. This means that there are no characters left. So if there are no characters left, if we have a depth, right, which is extra, or if we need to flip current, then we haven't done it, because that means that we need to do something, but we haven't done something. So this is return infinity, right? Otherwise, we're good, and then we return 0. I guess you can see that return 0. I don't have to type. That's and then the rest. So that's the base case. Characters. Otherwise, and I kind of wrote this in a funky way, but bear with me. But this is just the sentinel value is infinity. We get the first bit and the second bit if forced to flip it now, right? So then now this is just if we have a carry bit, then we have to flip the current bit now, and then now is if bits are equal, then we don't have to do anything. We just go to the next bit, and in fact, you can't do anything. I mean, I think I struggled with this a little bit during the contest. Is that I wonder if you could do 2 operations, but I feel like that's really expensive. And then in that case, I think there's an exchange argument where you could just do, just do like. What I mean by 2 operation isn't doing the same operation twice. That's obviously dumb. Well, I guess this other thing may be obviously dumb too, but it's doing this once and then this once, right? But in that case, you're paying 1 plus x when you can just swap index plus 1 and the future one that you're going to use it on or something like this. So I think in that sense, it doesn't make sense. So in that case, if the bits are equal, then there's no carry bits, and you just keep the bank account, as I would say it, the same. Otherwise, you have this one, and this one it is. I'm just copy and paste to kind of highlight this a little bit. So this is the we choose the index I now. That means that the next index has to be I plus 1. So then you set it to true, and it costs 1. So that's hence the plus 1. And then the second thing. And this is the second move of, choose index I. The cost of this is I, right? So this is choose index I, right? So yeah, it chooses this as index I. So by assumption, by definition, we have no carry bits because, we already either used it or whatever. But then now we have 1 extra things that we have to choose for J in the future. And then we have to add X, right? That's the cost of it. And this particular thing is there was an I in the past, use J now. So here, there was an I in the past, you can use J now. I think you can also rewrite this in a different way such that you can have negative, but I think that's just unnecessary complication, so I didn't do it that way. But basically this burns a J, so you can kind of figure out the state, which is going to the next character. You could, do force and X minus 1. So so that's pretty much it. That's the entire thing broken down, and this is a kind of a brute force memorization kind of thing. And so what's the complexity here, right? Well, index can go okay, let me start a little bit. So time complexity is equal to total number of inputs times time per input, right? And number of inputs is going to be equal to, well, index is 0 to n, current is going to be true to false, or true or false, so 2 of them. And extra can also go from technically 0 to n. Maybe you could say 0 to n over 2 if you're really careful. I didn't really implement it this way because it actually can run faster if you kind of do that up. It'll be twice as fast, right? If nothing else, because you're like you're cutting off the branches that will always be impossible. But I don't make that optimization unless I am forced to, which maybe I should have looked at it real quick. So it didn't even take a second, so I'm not going to worry about it. Even though, it would have been nicer to check that out earlier, I guess. But in any case, Yeah. So those are the number of inputs, and you can see that this is all of n squared inputs, right? And time per input, as you can see, should be all of 1, right? And also that's the space per input, whereas we only do either 1 lookup or 3 lookups. And yeah, so that means that total time is going to be all of n squared, and also space as well. Yeah, lazy, I'm just gonna write it that way. But yeah, so that's how we do the time and space. However, keeping in mind that if you kind of look at this very carefully, you can see that there's some like index plus 1 things, which means that there's a easy way to kind of, for some definition of easy, you have to practice this a bit, but you can convert this to bottoms up. And once you convert this to bottoms up, you can also do the space optimization. And of course, then in that case, it'll be all of n squared time, but all of n space, which is kind of nice. Yeah, that's all I have for this one. I'm going to show you I guess this is the top, but I'll show you the top of this thing, and then this function, the cache function, the DP function, and then just the bottom, I suppose, which should be straightforward. Anyway, that's all I have for this one. Let me know what you think, and you could watch me solve it live during the contest now. Right? Greedy? I think so. Okay. Wasn't sure, to be honest. Had to think about that one a little bit. Alright. S1, S2, same size. X. S1 number of times, 500. Think about it, okay? Choose I and J, and then swap, and it costs X. Choose I such that it is less than n minus 1, and then flip. So just adjacent. Adjacent is 1. Swap is X. Find the minimum cost such that to make the string equal. Is it DP? I mean, it's probably DP, but 500, so suffix for 500. I guess, yeah, I guess that's just DP. Is it? It is DP, but I have to be careful. I have to make sure that I prove the thing. So if it's 1 and it's 0, then you have to swap with a 0. Right? Otherwise, but if it's 0 and this is 1, it's probably fine because it, by definition, you're going to get swap in the future, maybe. Okay, let's try that. I don't know if that's true, but we'll try it. Just shortcut it. Right. So if otherwise, okay, if just skipped, well, you can't always skip it. So minimum, okay. Okay, otherwise, like I do 0, 1, and the assumption is that if you have a 0 and you have a 1, then it gets swapped out in the future. So is that true? then in the future, that means you're doing a 0, 1, so you just skip the 0, 1s. Okay, fine. Or do we have to count the number of folding? Yeah, you have to count the number of folding a little bit. But then that becomes 500 cube. This one. Anyone self Q4 yet? Oh, 4 people. I mean, more people self Q4 than Q3. How do I think about this one? Is there another way to do this one? I would do this one more than one. If you carry one forward, but then that's already n cube. Do we only ever do this? I guess we only ever do this if it fits this current thing. Between this 1, 0 and then you have 0. No, I guess you can have 1, 1 and then 0, 1. You still want to move it forward. This is a hard one. People are getting it slowly, finally, but am I misunderstanding what flipping means? I misunderstood this problem. That is terrible. They have to define what flipping means. Okay. Okay. I mean, they do define it, but I don't know why they define it afterwards. Okay, I have to. Okay. Let's think about. Oh man, I am solving the wrong problem. Okay. Okay. I don't even know what flipping means. This is a flipping problem. I guess that's what it means. Okay. All right. All right. Let's think. What does that mean now? Now that you wasted 5 minutes on the wrong problem. Okay, so that means that you have to do. I mean, it's probably still DP, but I think there's another state of carry. Now carry only carry 2. Right? Maybe 2 things. So, okay, so now current and extra. Right, so okay, I think I got this. But I misread this problem so much. Alright. Okay. So if index n, if extra is 0, return infinity. Otherwise return 0. extra is not equal to 0. Okay, and then now press is equal to infinity. And what we want to do is, okay, so if s1 index is equal to s2. Current is force. Well, okay, so if current, I guess I'll just don't confuse myself. If current, then yeah, okay. So the bit 1 is equal to s1 int. B2 is equal to s2 index, okay. And then if current, then that means that we swap this one, then okay, right. So then now, if they're the same, then we're good. We have no carryover, and we just keep the number of extras, and then and this costs nothing. Okay. Otherwise, we want to do the +1, right? So, but only if they're not the same, right? Because otherwise you can't do it now. Well, I guess you could do 2 operations, but that seems suboptimal. So maybe I'm wrong with that one. Okay, so if it's not true, then you could do true extra +1, right? Okay, yeah. Or you can do keep this false, but extra +1 plus x, right? Or if extra is greater than 0, then you can just use one of the extras that you used before, that you passed on before. So then now this is extra -1. Okay. So I'm doing infinity somewhere. Oh. I guess this is just an else. Yeah, because it's the same, then you don't want to use, you can't use any of these anyway, I think. Okay, but then why do I return this? Oh, because it's not possible for some of these. -1 and 3. That's not right. Okay, well. If only I didn't waste it like 6 minutes misreading it. I mean, I guess I know what flip means, but it's a little bit weird. It doesn't get used that much, so. Why is this 3? So 4. Okay, so this goes 3 because this thinks that you can go to flip the first one, and there's a true. What are these states? 0. So you get to the last one, force and 0. And pass is 1. What? So let's see, 174, force and 0. Force and 0. Why? How? Tell me why. If extra is greater than 0 or not current. Three and okay, 3, that's fine, and then 4. But 4 is not the same, right? So that means that 4 is not the same. So it's either doing this or this. Or this. No, 4. But 4 force. So it should be Okay. All right. So right. So 2 is true, and 2 true and 0. So that means that we swap. This is 1. 0 0, right? So then now we have 2 true and 0, and that's good. But then now we have 3. 3 false and 0 should not be returning a number because it goes to false. Oh, it goes to 4 false and 0. Yeah, 4 false and 0, so this goes to 5. This is true, so this is going to return infinity. Right? This is also going to return infinity. So why, how? Okay, so this is going here. But why is best 0? Oh, why is best 1? Is this thing? But this is true. Oh, this is just if that's it. 4 and 1, -1. Okay. Wow, that is a silly bug. I just kind of had a logic for like 5 minutes. All right. Yeah, let's give it a submit. Okay. Silly mistake. Oh man. And just misreading that problem for a long time. All right. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, today's contest, today's explanation, everything in between. Yeah, stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.